This is the last section of last week's. I tried to divide all the things up so we had about the same number of questions and the same length. It worked out for most of them except the first couple, which went a little long.
It's a long line.
Yeah.
Maps.
Yeah, the calculator stuff slowed things down. And that's important because I missed a question because I got a different calculator because I forgot mine and I couldn't work.
Something right here, right?
And it's one I had worked that problem numerous times, but I never bothered to memorize the answers. So I guess. So we'll talk about some RF interference and noise and line noise and DSP filtering to get rid of noise, common mode currents, surge protectors and single point ground panel, which will come up again in the last week when we talk about safety. Atmospheric noise is broadband and it's kind of continuous as opposed to a lot of man-made broadband noise, which is impulse. Things like motors turning off, switches, welders will really send out signals. So you have to use different things to eliminate them. One of the features in most of the modern transceivers is a noise blanker, which actually just attenuates the input signal for a period of time. It doesn't do any good if it's atmospheric noise because that's not impulse. I mean, it's there all the time. One of the problems is because it blanks the signal for a fixed period of time. You can actually eliminate a signal like CW because it's so narrow. So when you're, depending on exactly where the noise that you're trying to get is, you may actually wipe that out. And you may also create some additional distortion due to the fact that you're basically clipping the signal. So which of the following types of noise are removed by a noise blanker?
B.
Impulse noise. What undesirable effect can occur when using a noise blanker? I can't say I totally understand the mechanics of that, but
Same as the electronic here where you can see what's going on once there's noise loss from dust.
yeah, but why it creates spurious emissions part, I'm not sure I understand.
Here,
Huh?
here also cause for here suspicions.
Because they define spurious as signals you don't want. That's one of the definitions later on.
Okay, I just like the word here was the key here is like, okay, I can go with that if it's just appear to be
Not real.
serious.
Right.
You're not can't cause spurious emissions.
For sure.
But and it could be too the just the that it finds it momentarily opens, you know what I mean?
Right. Because it's going to have a sharp rise and fall time. Typically, that tends to generate harmonics. A lot of the newer receivers have built-in digital signal processing, but there's also standalone. Picture one there. I think that's a little pricey, but Apparently it works fairly well, where you can filter out you have a lot of parameters you can change and filter out lots of types of noise with them. Maybe not so many controls built in on the radio itself, but they're good at doing broadband noise, which the blanker won't. And also power line noise. I don't know about you. I have a power line 20 feet from my antenna. I do tend to pick up noise. Which of the following types of noise can often be reduced by a digital noise reduction? So, we'll get our first, all these for the day. Some have an automatic notch filter, sometimes called an ANF, and it can recognize the signal and actually set up a notch to filter it. And like I said before, like the noise blanker, it can actually, for something like CW, probably also a digital mode. If it was enabled, it would probably eliminate that too, because of the fact it's so narrow and you're trying to filter out a much wider signal. There's a picture showing what the audio spectrum looks like with that notch in it. So what problem can occur when using an automatic notch filter to remove interfering characters while receiving CW signals? So if you hear a roaring or buzzing line, it's probably caused by something switching, like arcing contacts, things like the doorbell switch operating the transformer. I don't know, they're talking about illuminating displays, assuming they're referring to the neon sign type, where it's using about 30,000 volts. Do that, so they do put out a lot of noise.
And just so you know, the more socially unacceptable you are, great and tragic.
Well, yeah, mine doesn't interfere much either, and I don't have a neon sign anymore. I used to have one of those transformers when I was in high school and made Jacob's ladders. It was really cool. So if you are sensing AC line noise, you can put in a line filter. There's a picture of a typical one there, which is really an LC network, especially on electrical motors. They used to talk about just putting capacitors on, but they kind of changed this a little bit to doing the line filters. So which of the following can create intermittent, loud, roaring, or buzzing AC line interference? Oh, all of us. GI? Huh?
That's all of us.
Yeah.
Being sworn.
I have a filament heater for my 3D printer, and every time it cycles on, it even affects Bluetooth. I get all this. What is used to suppress radio frequency interference from a line-driven AC motor? Revert source filter? We'll go with it. Common mode currents. Common mode is just a current that appears on all the conductors. One of the things you normally hear about is common mode current on your feed line or transmission line, where it actually travels on the surface of the shield, where the center conductor and the inside of the shield are balanced. So they have equal and opposite currents. So any differential current comes down the outside. The same thing's kind of true for just other cables. You can have a common mode current that travels on all of them, in addition to whatever differential currents you have traveling on the conductors.
Clay's doing current songs, I guess, seminar at the manifest. It's gonna be one of the blocks this year. Before. Well, can you explain?
Did you go to the common mode choke build?
I did. And it is amazing how much. It's a lot of times during the ratings, you'll. Stage door. It is. It's nice.
Well, that's a long conductor, and any fields are going to create a current in it. Which of the following can cause shielded cables to radiate or receive interference? What current flows equally on all conductors of an unshielded multi-conductor cable? In an automobile, the main source is typically the alternator. It used to be worse when it was a generator, where it had a commutator. So one of the things that you do is make sure that you connect your radio directly to the battery with as short as leads as you can, and put ferrite chokes on the leads, which will help. And like most things, you can't have too many ferrite chokes. It's just that they're not cheap. How can conducted noise from an automobile battery charging system be suppressed? Actually, I was confused on this one, even though this is the correct answer. But C sure looks good. I'm not sure why it's not. Okay, computers, laptops, desktops, towers, they have clock signals in the gigahertz, so they don't necessarily worry about interference in the computer itself. They generate a lot of spurious signals. So it usually looks like you're getting some kind of a varying modulation, different frequencies. A lot of times you'll see like a picket fence on your spectrum display. I see that every once in a while. I'm not sure what it is. It's not my computer, but it'll pop up every few kilohertz and just be just right down. It's very easy to space. And on multiple bands. What type of electrical interference can be caused by computer network equipment? Switching power supplies, another source. Most people are using a switching power supply to power the radio. So they've gotten a lot better. However, some of them do put out a lot of noise at the switching frequency. In some cases, I have one that allows you to change the switching frequency. So if it is causing a problem, you can adjust it. Although I have so much power line noise and other stuff, I don't know if that's a problem or not. What causes interference received as a series of carriers at regular intervals across a wide frequency range?
Which was fun. Bring our head there.
Yeah, but that's not a wide frequency range. It's from high up, right? Oh, this is the rusty bolts on the tower bit. I've never actually seen that, but they keep saying that, you know, it happens. But I guess you have, if it's on the transmitting tower, so you're in a relatively strong field, and you got corroded joints that can act, that oxide acts like a detector, so it's a nonlinear mixture. So it can generate intermodulation signals and I guess re-radiate them. So at least in theory, all that happens. What could be the cause of local AM broadcast band signals combining to generate spurious signals on the medium frequency or high frequency bands? Proper grounding is using a single point ground, so you connect all of your equipment. In this case, they recommend that you connect all of your surge protection or lightning protectors to that common single point ground so that the lightning gets to ground at the same time at the same point. I can't say I've actually looked into that and totally understand why it should make a difference. I'll believe them for now. It kind of makes sense, but I don't understand this. Why it would make a noticeable difference. So what's the purpose of a single point ground panel? Delta? Yes. I actually thought it was to keep all your stuff at the same potential, which on week 8 we'll talk about. Where should a station AC surge protector be installed? All right. That was an easy one.
We like easy.
Huh?
You like easy. So kind of question.
I'll take them all.
Give us to one of the tests, like, get really well. It's pretty easy. So it's like, why don't you save the option car? They're testing. I'm gonna do this. I'm going to be like, and then you look at your uses.
Every test is a little different.